Hey everyone, it's Jamie, and in today's video series, we're going to take a look at some simple and multiple linear regression problems. We've got some data here with monthly rents, and we've got variables showing us the number of bedrooms that an apartment has and the number of bathrooms that an apartment has. And we're going to use this as an opportunity to ask ourselves which factors influence the rental price of apartments, right? Is it the number of bedrooms? Is it the number of bathrooms? Which one of those two is most important, and is it possible that they both affect the price of an apartment? So to answer this question, we're going to do a few things. We're going to start by creating and comparing two simple linear regression models. One looking at the relationship between the number of bedrooms and monthly rent, and then a second one looking at the relationship between the number of bathrooms and monthly rent. We're going to compare those by looking at the coefficient of determination, the R-squared, to see which one has the stronger relationship. And then we'll also see whether or not the relationship between beds and baths is significantly related to the amount of rent. We'll do that by doing that hypothesis testing, right? Where we test to see if we test the hypothesis that the slope coefficients are really zero, and we're going to use the 5% confidence level. When you get done, you're going to end up with something that looks like this. Zoomed out, I'm sure, but I'll zoom in just a little bit to give you an idea. We're going to define our hypotheses. We're going to plot first rent and number of bedrooms. We're going to add the equation in the R-squared. Then we're going to create Excel's summary output, which we're going to use to interpret the model and see how strong the relationship is and whether or not it's statistically significant. We'll then do the same thing for number of bathrooms. We'll first plot monthly rent and number of bathrooms using a scatter plot. We'll add the equation in R-squared, and then we will summarize the output using the regression function in the data analysis tool pack, and we'll summarize it. So if you feel like you can get from the data to this step, great. You can jump ahead to the next video where we focus on interpreting. If not, stick with me. Okay. I've set myself up with two columns or two sections. I might have to move these around, but let's again refresh ourselves with the data. In column A, I've got rent. I have column B hidden, but in C and D, I've got bedrooms and bathrooms. We're going to address these two variables, bedrooms and bathrooms, separately. Why? Because it's nice to know the individual effect of the two different variables when you're going to build a multiple regression model. It gives us the ability to say, well, which is a stronger predictor? We can't really tell when they're both in the model together, especially because things like beds and baths are often related to each other. It's really weird to see a house with one bedroom and 6 bathrooms, right? That seems odd. So we'll build them individually and then add them together. So if I were to phrase this technically, kind of to see what we're doing, I'd say we're going to create a simple linear regression model that estimates the relationship between the number of bedrooms in an apartment and that apartment's monthly rent. We'll then test for significance of the coefficients at the 5% level. And we're going to look at the coefficient of determination, R-squared, to see how strong the relationship between the number of bedrooms and monthly rent is. So our estimated regression equation is y hat, which is monthly rent, is equal to an intercept plus a slope, beta 1, multiplied by the number of beds. And the hypothesis test that we run implicitly in all regression models is just the null hypothesis is that beta 1 is 0, that it doesn't matter how many beds you have. The price of an apartment is independent of number of beds, right? If beta is 0, they're not related. And my alternative hypothesis is just that beta 1 is not 0, right? That they are related. If you change the number of bedrooms in an apartment, rent will change. And the p-value we compare here is the p-value for beta 1, right? Which is the slope or the coefficient for number of beds. And that's just going to give us the probability that the null hypothesis is true. So that p-value says, what's the probability that beta 1 is 0, which would mean that beds and rent are not related. And our R-squared in this example is our coefficient of determination. So I'm going to plot and then I'm going to create the model. And I'm not going to do much interpretation. If you want interpretation, come back for the next video. So I'm going to walk through just the execution. I'm going to start by making the scatter plot. I want this scatter plot to include rent and number of bedrooms. I'm going to insert the scatter plot. Here it is. If you see the problem already, I appreciate that. But what's my problem? My problem is that rent, which is my dependent variable, is on the x-axis and it should be on the y. So I'm going to use the select data function, and I'm going to swap out the x values with the number of beds, or bedrooms, right? And then I'm going to swap out the y values with the monthly rents. I'm going to say OK. And now this chart is looking better. We've got number of bedrooms on the x-axis, monthly rent on the y-axis. I'm going to title it monthly rent and number of bedrooms. I'm going to remove my lines. Boom, boom. I'm going to add chart elements, my horizontal axis and my vertical axis, which I'm going to change the names of. Monthly rent, minding my capitalizations. Number of bedrooms. Then I'm going to add a trend line with the equation and the r squared, and I'm going to move it down here and get it out of the way. So before I move on, while we're still in practice, I know that I'm going to need to do the same thing for number of bathrooms. That was a bit of a rigmarole. Let's do it right now. I'm just going to copy this and paste it. Then I'm going to click on any one of the dots, and my lines are my data that I am using is going to be highlighted, and I'm going to drag the number, the x variable from bedrooms to bathrooms. This now changes the graph, and the equation changes automatically. Now what I need to do is change two words. And I've got my second graph. I'm not going to interpret them, but you should take a quick look. And now we're going to jump back over here to number of bedrooms. Excellent. Next step, use the regression tool in the data analysis tool pack to do the linear regression. So I already have done this, so I'm kind of queued up, but my y variable range is rent. My x variable range is number of beds. I've got labels, and I want to take this output and I want to place it right below my graph. Oops, I changed my x range. We can do it again. When this pops up, I'm going to reduce the number of decimals by changing it to a number. I'm going to double click on the cells so that it should enlarge. I'm going to zoom in on it. And then just so I have enough room, I'm going to remove the second confidence interval because it gives them to us twice. Okay, now let's zoom out. Looks to me like I need some more space, so let's just drag these things out of the way. Then take 2. Data analysis tool pack, regression. we're going to be all set up, with the exception of needing to change our X input range from bedrooms to bathrooms. I don't want to put it in F31 because F31 is taken. Let's try N31 and say OK. Format number. Double click on a space to give us enough space. And there we go. Now we have got plenty of room to tackle our interpretations, which is what we're going to do in the next video. All right, see you in a minute.